Hello students, this is our tutorial now, and I have continued. I have started to solve linear problems. So I have already completed graphical methods for two decision variables. And now I will start a simplex method. Already one video is lost. You can watch this video. Just subscribe this channel. So must subscribe first to get the videos. And if you like these videos, then like me, comment me, subscribe to get these videos. So now in another problem by using simplex method I will solve today. So let's start. This is a problem of maximization. This is by max g8 is equal to 2x1. Here are two decision variables given. It can be solved also by graphical method. I will try to solve later. First I will use simplex method and then graphical method. There are two decision variables given. Subject to subject to there are two constants given, 2x1 plus 5x2 greater than equal to 10, as a constant is greater than equal to, and another constant is 3x1 plus 8x2. Two decision variables, so two constant enough. So it is not necessary that two decision variables, so two constant. It can be more or less. This is less than equal to constant. Here x1 and x2, x1 and x2 are greater than equal to 0. And the constant are as that decision values always be non-negative, equal to 0. Now we have to transform it first as a equation. So both are constant. One greater than equal to and one less than equal to. So we'll for greater than equal to problem we'll use surplus variable, which minimizes the left hand side. Left hand side is greater than right hand side, so we will use a surplus variable. In this way, 2x1 plus 5x2 plus, sorry, minus, it will minimize, minus x3 is equal to 0. Now it is equal to 10. Sorry. Now it is equal to 10, and for it is less than equal to, so I will use select variable. Surprise variable always negative to minimize the side and makes equal or equation with the other side, and select variable is the positive one, which maximizes the quantity of any side and equals to the other side. So this is now we use select variable 3x1 plus 8x2 there will be 0 minus 0 and put in here 0x3. Here x3 will not be. Here we will put in surplus select variable x4. So here x4 is not used. So we put in this way 0 x4. Now this is 4. This is equal to 24. Now a surplus variable is introduced, and also a slack variable is introduced. Both the constant and both the constants are made or transferred into equations. Now we have to take that like x1, x2, x3 and x4 also non-negative. I have already given my negative sign, so x3 must be non-negative. x4 greater than equal to 0. Now it can be written in matrix formulation. Through matrix formulation, it can be written in this way. And I will write later the maximization of objective function actually. So, look how it can be written in matrix form. There are 2 row and 4 columns. There are 2 3. This is the first column. Then 5 8. This is the second column. Then -1 0 is the third column, and the fourth column is 0 1. So 2 rows and 4 columns, and the division variables are written in column matrix. Column matrix means x1, x2, x3, x4. This will be equal to a column matrix which is of 2 rows, 10 and 24. 10 and 24. Now it is written in the matrix notation. What we will have to do, we will take this matrix, first matrix, as A matrix, and the column matrix of division variables will take as X, and the last matrix will take as B. Then it can be written as AX is equal to B. Now this is there are 2 rows, so we have to find out 2 independent, mutually independent 2 column vectors. We will treat this way column matrix as vectors. This is E1, this is E1, this is E2, this is E3, and this is at last F4. So in these column matrices or vectors A1, A2, A3, 4, we have to find out 2 linearly independent vectors such that we can very easily find out the solution. So I am reading this. Actually, we wish to make a basis for the matrix A. So for the matrix A, we need to find out 2 linearly independent vectors. So we will take, if we will take A1 and A4, we can take any 2 vectors. So we first are taking and for A1 and A4 both. If we will find out the determinant, what will be the determinant value? 2, 3. If both are linearly independent vector, then its determinant will be non-negative, means non-singular, 1. So its value is 2 minus 3, is not equal to 0. So we can take as a basis. So we will take basis matrix as 2 3. If it is equal to 0 singular the determinant, then we cannot take the vectors as linearly independent. We cannot make form the basis, but this is non-singular, so we can generate the basis taking these two vectors 2 3 0 1. So we have already formed the basis of the matrix, and now the decision variables are which is, so with this vector a1 the corresponding decision variable is x1, and with this vector or column matrix the decision variable is x4. So the basic variables will be axb will be x1 and x4. Others will keep equal to 0, means x2 will be equal to 0 and x3 will be equal to 0, and we will just find out the value of x1 and x4 taking the basic variables, and b as well. B is 10 and 24 the column matrix. Then xb will be what will be the b inverse. Now if we replace in place of, we'll take the other column matrix as 0 0, so we need not, we'll take the other decision variable 0 equal to 0, and if we will multiply then we will get nothing, we will get, we can then deduce this form in this way. B, because x2 is equal to 0 and x3 equal to 0, we can deduce this form in this way. B into xb equal to b, and we used to know what axb, so we will take in this way. If we multiply both the side b inverse, then b inverse and b will be identity matrix, and with multiplying with identity matrix xb will be xb, and here will be xb, and multiplying with the b inverse with the right side we will get b inverse b. So we have, if you wish to know the basic variables, we have to calculate b inverse b. So we have to know what is the value of b inverse. Here b inverse will be very easy. The determinant value is what? 2 minus 2, just this will be 0. So 2. So 1 by 2 I am taking first, and then we'll take the cofactors. So this will be 1 and 2. 1's cofactor is 2, and zeros, yeah, is 0 will be 0, and 3, 0 cofactor is 3. As transposing it, it will be minus 3. 0's cofactor is minus 3. If transpose, then it will be minus 3, and 3's cofactor is 0, minus 0, so 0, and transposing we will get 0. So b inverse will be this. Now if we'll put here, then what will we get? I hope you are understanding what I am discussing. So now exb will be b inverse value is half 1 0 first row, minus 3 and 2 the second row, and b is 10 and 24. So if we calculate this value, what will be? We will keep 1 by 2 Here we'll get 10 and 0 24 0, so 10, and here we'll get minus 30 and 48, minus 30 plus 48, so it will be minus 30, 30 and plus 48, so it will be 18. And by dividing with half, by multiplying with half, both will be changed, and it will be 5 and 9. This will be 5 and 9. So we have find out the basic the values of the basic variables. So basic variable is made of x1 and x4. So x1 what will be? X1 will be 5, x4 will be 9, x2 will be x2, and x3 will be 0. And what is the value of the objective function? What will be the z? Remember, z maximize z is equal to z was given 2x1. Oh, sorry, I have not changed the objective function. Actually, it will be transformed in this way, minus 3x2. I have not here introduced that surplus and sec variables. It will be plus 0. It will transfer the objective function with using the select and surplus variable will be transferred in this way, plus 0 x4. If we put the values of the basic variables and non-basic variables, then we will get just 10. Just 10. x4 is multiplying by 0 is 0. The others are 0. So we will get 0. 10. So maximum value of the objective function is 10. But it can be improved further. This is the question in the linear time for the hard question topic is that the with this result we can be satisfied, or we can further maximize this optimal solution. So this is the question. We have to check it out. How we have to check it out? We have to find out the non-basic basic non-basic vectors. So x2 with respect to h2, the non-basic vector will be y2 equal to b inverse a2 a2 vector. So what will be its value? B inverse is given so here B inverse is given. We have already found out. This is 1 by 2 1 minus 3 0 2 a2. Remember the vector a2. You can go back with the video by playing back the video. You can watch that a2 was given. I have written in my exercise paper. This is actually a2 is 5 8. In my exercise paper it is written this is 5 8. You can playing back find out this. So multiplying this we will get the value. I'm writing directly. It will you in the same procedure, not the other procedure. You will get 5 by 2 and 1 by 2. Now, so the first one, this is considered it as y12 because one was x1 was the uh, decision variable, basic variable, and this is considered it considered as 4 4 2 because x4 also was the decision variable. So these two terms, this is carefully note. First element is 512 and second element is 4y42 because 1 and 4 are the related with the decision variable, no basic variables, basic decision variables. And y3 what will be? Y3 will be again b inverse e3 here, and if we put these values again, then it will be 1 by 2 1 0 minus 3 2 and the a3 vector I am again writing here minus 1 0. If we will solve this again, then we will find out. I am again directly writing, we will get 1 negative. This is the 4 point, 1 by 2 minus 1 by 2 and 3 by 2. Here one point in the previous video I have said that. So what is the concept? It will be y 1 3 and it is y 4 3. Y 4 3 and this is y 1 3. Y 1 3. One point is that if these non-basic variables are positive, all the elements in positive, then it does not matter. Here, both the elements in this non-basis variable is positive. So y2 is satisfied, but y3 there is one element is negative. Then y3 will enter in the feasible solution, means in the basis was found by taking independent variables. So y3 will enter in the basis, and if y3 will enter the basis, then here the first element y13. So 1 is related with the first element reason variable a1. A1 will be a3 will enter, y3 is related with a3. A3 will enter and a1 will will be out of the basis. Means it means that we will get more improved optimized solution. If all are positive, then the optimal solution we have achieved, this is okay. But if any element is negative in many non-basic variables, then there we have a chance to get a more accurate or more optimized value. So here, if both the elements are negative, then we cannot get the solution, and this will be an unbounded solution. So it is a good thing that just one element is negative, both are not negative. Otherwise, we will get unbounded solution. Now, how will change the basis now? Now, erasing this. Now, new basis will first form. Also, we can test which will leave and which will enter. So I have said that A3 will enter, and I have said A1 is out. Not it is a proper way to tell. Actually, we have to test that. How to test? We have to find out minimum xb1 by y13 and xb2 by y14. xb1 and xb2 already found out. This was 5 and this was 9. So minimum of it will be minimum 5 by this will be half. This will be 3 by 2. So here minimum cannot be taken negative also. Y13 is negative, so it cannot be negative. It is the negative value, so we have to take positive value. So this vector y43 actually will have to y43 is related with the a4 vector, so a4 not a1, a4 will be out. A4 will be out. So now the new basis what will be? Now the new basis will be will take with the first was a1 which is 2 3 and a3 is -1 0. A1 and A3 these are, so this is the new basis. You can very easily verify that the determinant value is non-negative. So these are linearly independent also. Very easily check. What will be the B inverse? B inverse will be, and this will be 0 plus 3. So 1 by 3. This will be 0 minus 3. This will be 1 and this will be 2. What will be the new solution? New basic solution. Now the decision variables are changed because the basis vectors are changed. This is u1, 2, 3. So this is u1 and this is a3. New basis vectors. So the decision variables are x1 and x3. Now the solution will be xb equal to b inverse b. If we will put here the values by 3, 0, 1, minus 3, 2, and this will be 10, 10 and 24. If we'll calculate this value, I have already done in my Excel book. It will be 8 and 6. 8 and 6. So now we have find out x1 what will be. X1 will be 8. X3 what will be. X3 will be 6, and x2 and x4 are 0. The non-basic variables are 0. x2, x4 is equal to 0. So the optimized solution we will find out. Z maximized Z will be if we put here again 2x1 minus 3x2 plus 0x3 plus 0x4, then putting these basic and non-basic variables, what we will get? We will get 16. This is more optimized. Earlier we will get maximizes you will 10. Now we are getting more optimized. So it can be further optimized. This is the question. So you will have to verify with taking non-basic variables. Non-basis vectors. I have done that y2 will be find y2 will be found y2 and y4. So y2 I have done. This is your homework to verify that these are correct or not. This is your homework. This will be inverse e2. It will come that it will be positive. The two elements are positive, 8 by 3 and 1 by 3. So both are positive. So it does not enter. And y4, it is already out, so it must be positive. You can earlier assume that, but yet we are verifying y inverse a4. This will come after putting the value 1 by 3 and 2 by 3. As I have already said, it actually out of the basis, so it must be positive. It cannot be negative. So both are positive. So no one can enter related with this non-basis vectors. No one can, vector can enter further. So we have already optimized. So optimized Z is equal to 60. It cannot be further improved. So this is the simplest method. I hope you like this video. So subscribe this channel. I earlier told that subscribe this channel to get this such kind of videos. I will continue to discuss simplex method further also. To get the all the videos, subscribe this channel and comment or to me and share it with friends. Thanks for watching.